Welcome back to the deep dive. So today we're doing something a little different.
A little bit.
Usually we take this, wide-angle lens to an industry or a trend. Today we're zooming in.
Way in.
Way in. We are essentially cracking open the skull of a modern network security system to see exactly how its brain works.
Yeah.
We're unpacking the source material for the Fortinet NSE4 FGTAD 7.6 exam.
It sounds incredibly niche, doesn't it? A certification exam. But you have to realize, this isn't just about memorizing which button to click.
Right.
The NSE4 is, well, it's effectively the blueprint for how Fortinet, which, they control a massive chunk of the cybersecurity market, how they think about security.
We're looking at the logic of the machine.
Exactly.
And for anyone listening who manages a network or honestly just wants to understand how your data gets from point A to point B without getting hijacked, this is fascinating stuff.
It really is.
We've got a stack of notes here covering 5 massive pillars: deployment, policy, content inspection, routing, and VPN.
Right. But we are absolutely not going to read the textbook.
No. That would be brutal.
It would be brutal for everyone involved, yes.
So instead, we're going to look at specific scenarios, actual concepts drawn directly from the exam questions that, force us to think like the firewall.
And this is the 7.6 version specifically. That's an important distinction.
Why is that so important?
Because version 7.6 introduces some, let's say, specific nuances in how the security fabric behaves and how routing decisions are made. If you're operating on older logic or even just general networking intuition, you might actually make the wrong call in these scenarios.
Okay, let's unpack this then. I want to start with the architecture, the master view.
Right.
One of the first things that jumps out is this concept of the security fabric. Now, usually when I hear fabric in tech, my first thought is marketing buzzword.
Sure.
Which means our stuff works together. But looking at question 1 in our source material, it gets very specific about a device called the root FortiGate.
Yes.
This seems to be more than just marketing fluff.
It is much more. It's a hierarchy. You have to imagine a network with, say, 10, 20, maybe 50 different firewalls. In the old days, those were islands.
You manage them one by one.
Exactly. The security fabric binds them into a single organism.
Okay, but what makes the root so special? Is it just the biggest box? The one with the most expensive processor?
And not necessarily the biggest, but the most authoritative. Question. One asks specifically about the primary responsibility of this root device. And a lot of people get tripped up here.
How so?
They think, oh, it must store all the logs, or it must provide the internet connection for everyone.
That would be the intuitive guess, right? The central brain holds the central memory.
But that's wrong. The correct answer highlights a very specific function, providing a centralized topology view.
Topology view.
Think of the root FortiGate as an air traffic controller. The controller isn't flying the planes.
Or fueling them.
Right. But they are the only ones who can see where every single plane is on the radar at the same time.
So it's purely about collecting telemetry, status updates.
Exactly. It collects that information status, link quality, device health from all the downstream members.
Yeah.
Without that root device, you don't have a map. You just have a pile of appliances.
It unifies the vision.
That's the key.
Okay, that makes sense. So zooming in from the whole network to just one box. Question 7 brings up VDOMs, virtual domains.
Virtualization. It's everywhere.
Right, slicing one computer into many.
Yeah.
But the material makes a really sharp distinction between a regular VDOM and a management VDOM. I think most people assume all virtual slices are created equal.
And that is a dangerous assumption to make.
Oh.
In the Fortinet world, a VDOM splits the physical firewall. So you'll have VDOM A for your guest Wi-Fi and VDOM B for, say, your corporate finance team.
And they're totally separate.
Totally. Separate rules, separate routing tables. They don't touch.
Which is great for security. If the guest Wi-Fi gets hacked, the finance database is safe.
Correct. But here's the catch, and this is what the exam drills into. Someone has to manage the physical box itself. Someone has to update the firmware.
Someone has to talk to the licensing servers.
Exactly. To prove you paid your bill. And that is the management VDOM.
So it's like a building superintendent.
Perfect analogy. Each apartment is a VDOM. You can paint your walls, change your furniture, that's your policy, but you can't fix the roof.
You can't pay the property tax for the whole building.
No. The management VDOM is the super. The answer to the question emphasizes that it is solely responsible for system-wide tasks. Firmware, connecting to FortiGuard for updates, NTP for the system clock.
So if I'm logged into the finance VDOM, I can't trigger a firmware update for the whole system.
Nope, the system won't let you. It's an architectural safety valve.
Okay, let's move to the brainstem of the operation, routing.
The backbone of everything.
How does the machine decide where to send data? This is where I feel like human logic and machine logic really start to diverge.
They absolutely do.
So looking at question 5, classic scenario, we have two different ways to get to the same place. Two roads. One is a static route, something I, the human, typed in. The other is a route learned by a dynamic protocol, like OSPF.
A very common setup. Manual backup, automatic path.
The question is,
Yeah.
how does the FortiGate decide which one to use? Now, my human brain says, check which one is faster. Or maybe which one has more bandwidth.
And your human brain would fail the exam.
I figured as much. So what does the machine look at?
It looks at something called administrative distance, AD. It's a fascinating concept because AD isn't a measure of performance.
What is it then?
It's a measure of trust.
Trust.
Yes. Every source of routing information is assigned a trustworthiness score. That's the administrative distance. But here's the kicker. A lower score is better. It's like golf.
Right. Okay, so what's the score for a static route?
By default, it's 10. Very low. Very trusted. Why? Because you, the administrator, explicitly typed it in.
The machine assumes I know what I'm doing.
It does. Now, something like OSPF, its default AD is 110. The FortiGate looks at the two options. It sees 10. It sees 110.
It chooses the 10.
Every time.
Even if the OSPF route is on a faster cable, even if my static route is pointed at a dial-up modem.
It doesn't matter. It doesn't even get to the point of checking the speed. The administrative distance is the first filter. The static route wins simply because it has a lower AD.
So the firewall prefers explicit instructions over learned information.
Explicit over learned. That is a great way to put it.
Okay, staying on this. How the machine finds things. Let's talk updates. Antivirus definitions, IPS signatures, they change constantly.
Hourly, sometimes.
Question 2 discusses how the FortiGate finds a FortiGuard distribution server, or FDS.
Right.
How does it choose which server to download from? Again, my logic says it looks at my time zone or my IP address and picks the US East server or something like that.
And again, that's too human. The default behavior is just ruthless efficiency. The answer to the question is that it selects the server based on the round-trip time, the RTT of a ping packet.
It just pings them all.
Essentially. It sends out a hello to the available servers. The one that replies the fastest gets the job. It's a drag race.
So if I'm in New York, but the server in London is having a light traffic day and responds 1 millisecond faster.
Your FortiGate connects to London. It couldn't care less about geography. It cares about latency.
It's self-optimizing.
It is. It removes the bias of location and relies purely on the metric of speed.
I like that. It feels resilient. Okay, we have to talk about SD-WAN. It's huge right now. Question 9 brings up the lowest cost strategy.
This is a tricky one because the word cost is ambiguous.
Right. When I see lowest cost, I think money. The ISP bill.
Not yet. In networking, cost is just a number you use to rank your preference. But the exam question highlights a very specific sequence of logic.
What's the sequence?
It's a two-step process. First, it checks the health.
Health meaning. Is the line actually working?
It's more than that. It's checking against an SLA, a service level agreement. Is packet loss below 1%? Is latency below 50 milliseconds?
Got it.
If a link is cheap, so it has a low cost, but it's experiencing 5% packet loss, the SD-WAN logic disqualifies it. It's out of the running.
So quality is the gatekeeper.
Exactly. Only after the links pass the health check does the system look at the cost value that you assigned.
So I could assign my main fiber line a cost of 5 and my 5G backup a cost of 10.
Right. And if both are healthy, it picks the fiber because 5 is lower than 10. But if the fiber starts getting jittery and fails that health check,
it fails over to the 5G, ignoring the cost.
Always. Health first, then cost. It prioritizes reliability over preference.
Okay, let's pivot. We've built the plumbing, we're routing packets. Now we need to know who is on the network. Identity.
This is where security actually happens. You can't secure what you don't know.
And the big buzzword is zero trust. Question 3 asks about ZTNA tags. To me, a tag is like a sticky note.
It's a dangerous oversimplification to think of them as just labels. In FortiOS, a ZTNA tag is a dynamic control mechanism. The question asks for their purpose, and the answer is that they identify the security posture of the endpoint.
Break that down for me, security posture.
It means context. It's not just, is this Bob? Is Bob's laptop running the latest antivirus? Is the firewall on? Is there a suspicious process running?
And the tag can change based on those answers.
In real time, that's the magic. Bob might log in at 8 a.m. with a compliant tag. He gets access to the HR database. At 10 a.m., he turns off his antivirus to install a game.
Oh.
The ZTNA client sees that, reports it, and the tag on the firewall instantly flips to high risk.
And the policy says high risk equals block.
Exactly. Bob is kicked out of the HR database. He didn't log out. His posture changed.
That's so much more powerful than just a password. It's continuous vetting.
It's the difference between checking an ID at the door and having a security guard follow you around the building.
A creepy but effective analogy. Speaking of knowing who people are, single sign-on. We all hate typing passwords. Question 6 talks about FSSO, and specifically DC agent mode.
Right, for Windows Active Directory environments, so most companies.
The question asks where this DC agent lives. And the answer is kind of in the name, isn't it?
It is. It's installed directly on the Windows domain controller.
Why there? Why on the server that runs the whole directory?
Because that is the source of truth. Think about it. When you unlock your computer in the morning, who are you talking to?
The domain controller. To verify my password.
Right. The DC agent is basically a spy sitting on that server. It monitors the security event logs. It sees user Alice authenticated from IP 10.5.5.5.
And it whispers that information over to the firewall.
Immediately, it tells the FortiGate, hey, that IP is Alice. She's in the managers group. Now, when traffic from that IP shows up, the firewall already knows who it is.
And Alice never had to log into the firewall itself.
Exactly. It's frictionless. But it all relies on that agent being installed right at the point of authentication.
Okay, segment 4. When things go wrong. Question 10 describes a virus coming down the wire.
The nightmare scenario.
It specifies we're using flow-based inspection. I know there are two modes, proxy and flow. Proxy waits for the whole file.
Right. Safe, but slow. Flow is real time. It scans packets as they stream by.
So here's the problem. If the virus is in the middle of a big file, hasn't the user already received the first half of it by the time the firewall finds the virus?
Yes, they have. The browser has started the download. The progress bar is moving.
So how does the FortiGate stop it? It can't reach into my computer and delete the file?
No, it does something more aggressive. The answer to question 10 is that as soon as it detects that malicious signature, the FortiGate sends a TCP reset packet.
A reset.
It spoofs a packet to both the sender and the receiver that basically says, close this connection and another.
It just hangs up the fan.
Violently, the connection is severed, the user sees network error or download failed.
And the file on my computer is just an incomplete, corrupted fragment.
Correct. It can't execute. It's junk. The firewall doesn't clean the file. It murders the transport mechanism delivering it.
Efficiency again.
Always.
Speaking of resources, question 4. A very practical problem. The disk is full. The FortiGate is logging to its local hard drive, and it hits 100%. What happens?
Well, I can't just stop processing traffic. That would be a denial of service. Unacceptable.
So what's the logic?
The default behavior is circular logging.
Like a loop.
Exactly. It automatically overwrites the oldest log files to make space for the new ones.
So if I need to investigate a hack from 6 months ago and my disk got full,
that log is gone, vaporized, overwritten by the traffic from 10 minutes ago.
That's a tough trade-off.
It is. I mean, ideally you're sending logs to a central server, but the device logic prioritizes current visibility and uptime over historical data. It assumes today is more important than yesterday.
Okay, last scenario. And this is one every single listener has seen. Question 8. The scary browser warning.
Your connection is not private.
Attackers might be trying to steal your information. We see this when we turn on SSL deep inspection. Why?
You have to understand what deep inspection is. It is, by definition, a man-in-the-middle operation. The FortiGate intercepts your encrypted chat with Google. It decrypts it, scans it, re-encrypts it, and then sends it to you.
To the browser, that looks exactly like a hacker.
Identical. The FortiGate has to sign that new re-encrypted traffic with its own certificate. The question asks why the warning appears, and the answer is that the browser does not trust that certificate.
It doesn't know who signed it.
Exactly. Google's certificate is trusted by default in every browser. The FortiGate's is self-generated. If you haven't installed that certificate on the user's laptop in their trusted root store, the browser panics.
So the fix isn't on the firewall, it's on every single endpoint.
Yes. It's a trust relationship you have to manually establish.
I want to leave everyone with a thought on that user experience piece. We talked about SSL inspection causing errors, ZTNA blocking access because you opened a game.
TCP resets, killing downloads.
Right, security's friction.
It is.
We're deliberately introducing these obstacles for safety. So the job of the modern network admin isn't just blocking bad stuff, it's calibrating that friction. How much are we willing to annoy the user to keep them safe?
That is the eternal struggle. If you lock it down too tight, nobody can work. Leave it too open, you get ransomed.
And the NSE4 exam is really just teaching you which knobs and dials you have to tune that balance.
Well said.
Thanks for taking this deep dive into the logic of the FortiGate with us. It's been eye-opening.
My pleasure.
Catch you on the next one.